Okay, here are the odd numbers on the core practice sheet. We're just going to work them out together. So we do need to be told that we're dealing with a geometric series, which we are here because I've got a first term, a common ratio, and a number of terms. Now it's just a matter of putting the parts in the right place in our formula. So just as a reminder, the sum of the first n terms of a geometric series is a1 times 1 minus r to the n power over 1 minus r. All right, let's put things where they go. So the sum of these first 8 terms is going to be the first term times 1 minus. Now here's the thing. When your ratio is negative, super important that you put that ratio in parentheses. If you don't, it's probably not going to do what you want. Everybody's going to end up sad. Same thing down below, 1 minus negative 3. And then let's pull up a calculator, see what we got. So I'm going to use the handheld for this one. I actually like to do it in 2 parts. Makes it a little easier than if you try and type everything all at once. So first, just the numerator. So 4 times 1 minus, and then in parentheses, negative 3 to the power of 8, and then close off those parentheses. So here's my numerator. I'm then going to divide that by 1 minus the negative 3. I'm just going to choose to use my head here to say minus a negative is the same as plus. And that makes things a little easier to work with. Put that all together, we end up with an overall sum of the first 8 terms of that sequence of negative 6,560. Negative 6,560. Let's go again. The sum of the first 7 terms of the geometric sequence that starts with 3 and has a common ratio of negative 6 over 1 minus negative 6. All right, let's pop that in here. I think I'll use a Desmos this time for some variety. So we're going to have 3 and then 1 minus negative 6 to the power of 7. And that's over 1 minus negative 6. You can, of course, convert that to plus 6 in your head. We're going to end up with a big number. I hope that makes sense. If we're multiplying by a number with a magnitude of 6, the numbers are going to get really big really fast in terms of their overall size. So 119,973 is muy grande. And then it was 973. There we go. Give these a highlight and then move on to the next. Once again, we've got a negative ratio. That doesn't always happen. It just did in these first several examples. So the sum of the first 9 terms of this geometric sequence is negative 1 times 1 minus negative 2 to the power of 9 over 1 minus negative 2. If you stay in Desmos, rather than retyping everything, I'm just going to change my details. Right? I'm just editing here this general formula. And that's going to get me to the same place, but without having to retype everything. So put that all together, negative 171 for the overall sum of those first 9 terms. Now, when it comes to these next ones, I do expect you to know that these are geometric series, even if it doesn't say it in writing. Notice this follows the pattern of a sub 1 times r to the n minus 1. It's a number times a number to a power. A number times a number to a power. A number times a number to a power. That's the setup for a geometric sequence. These are therefore geometric series. So how do we break it down? We break it down like this. Your first term you get by putting a 1 in for the k in this case. 1 minus 1 is 0. 6 to the power of 0 is 1. 1 times 2 is 2. It's not a coincidence that this number ends up being what your first term is. As long as this starts at 1, as long as your index starts at 1, and this has an index minus 1 for the exponent, that'll happen every time. The common ratio, well, that's this other number. That's what we're multiplying by each time. And we're looking for, as long as your index starts at 1, you can just look at the top. We're looking for the first 8 terms in this case. So here we go. The sum of those 8 terms is first term times 1 minus common ratio to the power of n over 1 minus common ratio. Coming back here, let's go to the TI this time again. So 2 parentheses, 1 minus. Now, if it's a positive number, you don't need the parentheses around it like we did with the -3. Not a bad idea to use them, but they're not required. And then you can do it all in one step. I did it 2 steps last time. You can do it in one. Just make sure that you put that denominator in parentheses. Otherwise, it's not going to do what you want. We end up with, a big one, 671,846. Again, I hope that makes a little bit of sense. If we're multiplying by 6, those numbers are going to get really big really fast. So 671,846. Give you a highlight and you a highlight. Next up, same deal. If you haven't already tried these, give them a try and then unpause when you're ready to check things. So I'm looking here. Here's my first term. Looking here. Here's my common ratio. Looking here. There's my number of terms. So the sum of the first 7 terms is -4, 1 minus 5 to the 7th over 1 minus 5. -4, 1 minus 5 to the 7th. Then divide that by, in parentheses, 1 minus 5. We end up with, negative 78,124. Negative 78,124. Again, this is a pretty big number. That's because my multiplier is 5. We're going up by powers of 5. Those get very big very fast. The further away from 1 your number is, the faster you're going to grow. Or if it gets to be a fraction, the further away from 1, the quicker you go down and come together. Okay, and lastly, for this example, it's again going to be 7 terms. There's your n, there's your first term, and here is your common ratio. So the sum of the first 7 is 3 times 1 minus 3 to the 7th over 1 minus 3. So 3's all over the place. Let's do a Desmos for this one again. 3, 1 minus 3 to the 7th over 1 minus 3 ends up being 3,279. 3,279. And again, I hope it makes a little sense that that got so big. Multiplying by 3 every time. Triple it, and triple that, and triple that. The numbers are going to get very big very fast. So the moral of that story is be mindful that your geometric series can be pretty big numbers. So you're going to need to be able to trust your calculations. Recognize that structure when it's written in sigma notation. Your first term going to be there in front, and then your common ratio going to be there at the back with the exponent on it.